All right, we're taking a look at simplifying square roots and cube roots. We have two problems. It's the same value in the radicand underneath the radical sign, but in the left I have a 24x to the fifth y squared that's taking the square root, and on the right I have the same value, but I'm taking the cube root. We're going to solve each of these problems, and I'll start off with the square root. So I'm going to solve this via the method by listing factors. This is the method I'm going to use. In order to do this, I need to know what the factors of 24x to the fifth y squared are. In particular, I'm looking for the number 24. And that is a prime factorization that can be approached a few different ways, but will end up in the same place. So 24 is equal to 4 times 6 is one breakdown that we could use, and 4 is 2 times 2, and 6 is 2 times 3. So these are my factors of 24, my prime factors. So I can rewrite my problem as 24x to the fifth y squared, square root of that, is equal to, by listing out exhaustively all the factors. I've got for the number 2 times 2 times 2 times 3, and for my variables I have x to the fifth, and I'll write that out, each one individually. X to the fifth is x times itself, so that there's 5 factors of x. And for y, I have y squared, so that is y times y. Next, I'm looking for pairs of the same value that I can pull out from underneath the square root sign. And I see that I've got a pair of 2's, so I can pull that out, a single 2. I have a pair of x's. I can pull that out as a single x. I have another pair of x's, and I can pull that out as well as a single x. And lastly, I have a pair of y's, which I can also pull out as a single y. When I do that, what I'm going to end up with is the things that came out of the square root sign are a 2 and another, nope, not another 2, just a single 2 and an x and another x and a y, and then I have whatever's left. That's a 2 times 3 times x. Now, I can simplify this by writing x times x as x squared and times the y. And then within the radical sign, I'm going to multiply things together. So I have a 2 times 3, that's a 6, and I have my x. And that is my solution. Okay, that is the square root. Now, if I want to do the cube root, we'll take a look at that. And I'll bring that down here. And we'll solve that in a similar way. Now, I have the cube root of 24x to the fifth y squared. And if I break it down by doing my list of factors, using that method, always works, I'm going to have just what I had before, except I'm taking the cube root. So again, I have 2 times 2 times 2 times 3 for my number. Multiply all that together and I get 24. And then I'm going to have x times itself, so that I have 5 x's. And I have y times itself, so I have y squared. All right, but for a cube root, I'm looking for not a pair of the same number or variable, but I'm looking for 3 of them, because the cube root is the opposite of something cubed, or something to the third power. So I see that I have 3 2's, so I can pull out a single 2 from that. I do have 3 x's, and I can pull that out. I only have 2 x's remaining, so I can't pull out any more x's, and I only have 2 y's there. So I cannot pull out any y's because I need 3 of them to pull them out. So I can rewrite this as a 2 I pulled out and an x I pulled out, and then I have my cube root of whatever is left. So I have a 3 times x times x times y times y. And what I'll do lastly is gather those up inside the radical sign. So I have 2x times the cube root of my 3, and then I'll write this as x squared, y squared. And that is my answer. So to review, we simplified 2 expressions. The first one, square root of 24x to the 5th y squared, and came up with the expression 2x squared y times the square root of 6x. And then we solved the cube root of 24x to the 5th y squared, simplifying that to get 2x times the cube root of 3x squared y squared.